Hello, I'm Ashley Rice.
And I'm Melinda Rose, and this is Light Matters for October 24th, 2012.
On today's show, twisted light is created on a chip, self-cleaning waterproof optics are pursued, atom optics comes of age, superparticles are shaped from nanorods, and we bring you some notable business news.
The smallest emitter of orbital angular momentum light that travels in a twisting corkscrew-like way, was created on silicon. The chip is 1,000 times smaller than any other such device reported to date and could be used in optoelectronics and communications technology. OAM light has been generated for the past few decades using bulk optics such as lenses and plates, but only recently have scientists tried to produce it using chips. The new emitters, invented by an international group representing universities in the UK, Scotland, and China, can be made using standard integrated circuit fabrication technologies, meaning they can be made at very low cost and in high volume. Such integrated devices and systems could open new applications of optical vortex beams previously unattainable using bulk optics. The researchers developed the chip with tiny microring resonators with angular gratings to trap and twist the light. The findings could jumpstart the use of OAM-emitting chips in optoelectronics and communications. The work appears in Science.
Inspired by butterfly wings, a new material that repels water and shines with beautiful, brilliant hues could provide the foundation for optical devices that are self-cleaning and waterproof. Over the last 10 years, researchers have been trying to create structural colors like those found in butterfly wings and opals, and in creating superwater repellent surfaces like lotus leaves. Structural color is the result of periodic patterns, while superhydrophobicity results from surface roughness. Trying to combine these traits in one material is a complicated multi-step process. Xu Yang of the University of Pennsylvania first used a holographic lithography technique to recreate the wing's reflective properties, using a laser to make a three-dimensional cross-linked pattern in a photoresist material. The resulting 3D lattice provided structural color. The surface's texture is made to exhibit the water-resistant property of butterfly wings by roughening it with a solvent. Materials with structural color could be used as light-based analogs of semiconductors, for example, or for light guiding, lasing, or sensing. As they repel liquids, superhydrophobic coatings are self-cleaning and waterproof. Such qualities would be useful for optical devices that are highly dependent on their degree of light transmission and on their ability to maintain surface dryness and cleanliness. The findings appeared in Advanced Functional Materials.
NASA is funding atom interferometry, a variation on the 200-year-old optical technique, in the belief that the emerging highly precise measurement technology will allow the detection of ripples in space-time and other so far undetectable events. A team at NASA's Goddard Space Flight Center, Stanford University, and AOSense Inc. recently won funding to advance atom optics, which some believe to be a technological panacea for everything from measuring gravitational waves to steering submarines and airplanes. Predicted by Albert Einstein's general theory of relativity, gravitational waves occur when massive celestial objects move and disrupt the fabric of space-time around them. By the time these waves reach Earth, they are so weak that the planet expands and contracts less than an atom in response. This makes their detection with ground-based equipment more challenging because environmental noise, as with ocean tides and earthquakes, can easily swamp their faint murmurings. To date, no instrument or observatory has ever directly detected them. Their discovery would revolutionize astrophysics, giving scientists a new tool for studying everything from black holes to the early universe. Atom interferometry obtains its highly accurate measurements just as optical interferometry does by comparing light that has been split in two by a beam splitter. The resulting interference pattern from the two beams is inspected to obtain highly precise measurements. So far, the team has designed a powerful narrowband fiber optic laser system that it plans to test at one of the world's largest atom interferometers, a 33-foot drop tower in the basement of a Stanford physics lab. And the team is also fine-tuning a gravitational wave mission concept it formulated that calls for 3 spacecraft. Each ship would have atom interferometers and would orbit close to one another to sense gravitational waves as they roll past.
Chemists at the University of Florida have developed a new technique for growing new materials from nanorods. Putting nanoparticles together creates new materials with collective properties. Such materials have the potential to revolutionize everything from data processing to medicine, but attempts to assemble nanoscale objects into sophisticated structures has been largely unsuccessful. The UF study represents a major breakthrough in the field, showing how thermodynamic forces can be used to manipulate growth of nanoparticles into superparticles with unprecedented precision. In the study, a synergism of fluorescent nanorods, sometimes used as biomarkers in biomedical research, resulted in a superparticle with an emission polarization ratio that could make it a good candidate for use in creating a new generation of polarized LEDs, used in display devices like 3D TVs. The work appears in Science.
4% of employees in the UK, more than 1 million people, work in physics-based businesses, a sector that could recreate the nation's economy, according to a recent study by the Institute of Physics. Produced in collaboration with Deloitte, the study assesses the physics-based businesses' contribution from 2005 to 2010. It was used to determine the effect of 2008's financial crash on the physics industry. The value added to the UK economy by physics-based employees is almost double that of the average UK employee. Since 2005, the number of registered businesses in the physics sector has risen by more than 30%, the study revealed.
Space Photonics Inc. has signed a deal with SHOT North America to commercialize its optical communications technology for U.S. military and intelligence customers. The laser-fire free space optical communication system enables uninterrupted, secure communications where high-capacity fiber optic cables have been damaged or are not available. Most systems of this type use large beams to maintain their links to accommodate for small mounting structure shifts, but the laser-fire uses low-power infrared lasers, making it impossible to detect and intercept beams while the system is operating, the company said. Manufacturing of the systems will begin later this year at SHOT's Lighting and Imaging Unit in Southbridge, Massachusetts.
Speaking of space, you can now register for Photonics Media's webinar on photonics and space applications, which will take place November 15th at 1 p.m. Eastern. Featured is Dr. Alexander Rabanchek, who will speak on using pulse lasers to remove orbital debris.
You can register on photonics.com or by clicking on the link in this video.
Well, that's it for this edition of Light Matters, Photonics Media's weekly newscast. We'd like to hear from you. Tell us what you like or don't like about our program. We welcome your comments and suggestions at lightmatters@photonics.com.
You'll find links to share and subscribe to Light Matters by clicking the Share with Friends button on your video player.
Thanks for watching, and we'll see you next week.